Okay, so today we're moving on to section 1.7. All right, and so in this section we're talking about piecewise defined functions, and we're going to talk about how to analyze their graphs as well. But before we do that, let's talk about the things that you'll know how to do at the end of this lesson. Determine whether a function is even, odd, or neither. Graph a piecewise function. Determine where a function is increasing, decreasing, or constant, and also locate relative minimum and maximum values of a function on a graph. All right, so let's start with even and odd functions. So it's based on the symmetry of our function. So is it symmetric about the y-axis, or is it symmetric about the origin? So if it's symmetric about the y-axis, which means it looks the same on either side of the y-axis, we call it even. And if it's symmetric about the origin, we call it odd. So origin goes with odd. All right, and so to see if a function is even, we just want to show that f of negative x is the same as f of x. So that should make sense, because if we have the y-axis, we'll have the negative negative x values over here, and negative, positive, all my words. If we have the y-axis in the middle, we're going to have positive x values on the right, negative x values on the left. So if we're symmetric about the y-axis, or even, our graph should look the same on both sides. So we want to make sure that these two are the same. And so for odd, we want to make sure that things in opposite quadrants are the same. Okay, so let's determine whether our function is even, odd, or neither. So part A, 17x to the third minus 12x to the fifth. All right, let's check even first. So we just have to show that f of negative x is the same as f of x. Well, we got f of x. Let's figure out what f of negative x will look like. So what does this mean? This just means we're going to replace x in our function with negative x. Okay. All right, so what do we know about negative things raised to the third power? It's still going to be negative. So we can actually remove the negative out here and put it in front of the 17, and we'll still have the same answer. Same here, negative x to the fifth. It's still going to be a negative answer, so we can put the negative wherever we want. So we have two negatives right here, which will make a positive. So we found f of negative x. So now we just have to compare. Is f of x the same as f of negative x? Is this the same as this? These are different. All right, so we can say that our function is not even. All right, now let's check to see if our function is odd. So we want to show that what we just found, f of negative x, is the same as negative f of x. So let's find negative f of x, because that's the one thing we don't know yet. So that's just putting a negative in front of our function. Now let's distribute this negative. Okay, so is what we got for negative f of x, is it the same as f of negative x? So this is our question. So this negative 17x to the third plus 12x to the fifth, is it the same as what we got over here? Yes. So that tells us that our function is an odd function, and it's symmetric about the origin. All right, let's do the same thing for part B. So let's check for even, which means we have to find f of negative x. So we're replacing x with negative x. Alright, so we have something negative raised to an odd power. That means we can just take the negative out and we'll have the same answer. But here, a negative squared is actually positive. So this is now positive x squared. Alright, so now we check, is f of x the same as f of negative x? Are these two the same? No, they're not. So our function is not even. To check to see if it's odd, only thing left to find is negative f of x. So we just put a negative in front of our whole function. I'm going to distribute that negative. So now we have to see, is this the same as f of negative x? So is this the same as what we got over here? The answer is no. So this is actually not odd either. Alright, finally, part C, which is the absolute value function. So it takes whatever's on the inside, x could be negative or positive, and it makes it positive. Alright, so we check f of negative x. Alright, well we just put in negative x instead of x. And this is going to give us whatever the positive version of this number is. Alright, well that does the exact same thing as the original. So our function is even. Let's see if it's odd. Negative f of x, we're just putting a negative in front, which absolute value makes it positive, but we're making that negative. So this is not the same as what we just found. So it's not odd.